Boom shakalaka. What's going on, everybody? Randall here from Crypto Love, and I am joined today by David Chen, the CEO, and Raymond Fu, an architect of MOAC. What's going on, guys?
Pretty
We're doing
good.
pretty well.
Yeah, so welcome here. So MOAC is the mother of all chains. So to get started, why don't you tell us a little bit about MOAC? Give us your elevator pitch.
Okay, so MOAC is basically a two-layered blockchain setup compared to the traditional, single-layer blockchain, and it solves a lot of problems that single-layer blockchain cannot solve. And that's the major point of MOAC do. And also, when we design the two-layer architecture, we create a depth-friendly setup, which is always the mind when we design this system. And there are a lot of details in the system that are doing that. So I don't want to get into too much details today, but that's pretty much what MOAC will do.
Okay, wonderful. So you talk about a multiple layer blockchain, and also in your white paper and other things, you've referenced it as a third generation blockchain or blockchain 3.0. So how does MOAC compare with other third generation blockchains out there, stuff like EOS or Cardano?
Yeah, I think we try to solve a trilemma problem blockchain typically has. So one is the security, and also decentralization and the scalability. So these three problem, it's very difficult to solve. And I think Ethereum tried to solve in the last 2 years, but they weren't able to. And I think because, you can easily achieve two of them, like EOS. They can do scalability and maybe security, but it's not decentralized because you don't have 21 supernodes. And what we do is we try to solve this problem at in a single blockchain. And I think we cannot solve in a single layer blockchain. We have to do it in a multiple layer way, meaning we have bottom layer, which supply the decentralization and security, and using the upper layer to solve scalability. I think that's the major difference between us and all other blockchain solutions like EOS, Ethereum, and some other sidechain solutions.
Mm-hmm. And so being that you have multiple chains, a mother chain and then the micro chains, you can have you can have proof of work on the mother chain, and then you can have many different other types of consensus on the micro chains as well. How do you guys get those to work back and forth together?
Yeah, actually, Raymond probably can shed some light on on this, because he's in charge of the one implementation of our one microchain called Faststorm. Hey, Raymond.
I'm sorry. I think my connection was bad.
Sure. So just how do you get the mother chain, which uses proof of work, to communicate back and forth with the micro chains, which could use DPoS or PBFT or proof of stake?
Do you want me to explain it, David?
Yeah.
Yeah, you can. You can explain, with the recent implementation of Faststorm.
Yeah. So this is how it works. In order to create a microchain from the mother chain, we need to set up a system. So basically, using those contracts, we can determine what kind of consensus the microchain will use. So we can use DPoS, we can use POS, we can use a ProcRin and Faststorm, which we created to create the microchain and use the different consensus. And periodically, the microchain will flush the status of the microchain to the mother chain. That way, we'll sync all the data from all the microchains to the mother chain. And of course, because mother chain is doing POW, it's gonna give the security needed for all the microchains. And to give you an example, one of the microchain that I'm working on is called file store. It is a consensus that is used for the microchain to be able to verify files. Using that file store consensus, we can create a blockchain that will implement IPFS, which is decentralized file storage. So using file store consensus and IPFS, we can create microchains that can be used as a decentralized file storage system.
Okay. And I was curious about the asynchronous smart contracts that you have running on these microchains. They all send data back to the mother chain. How is it that they can work asynchronously and still have the same information on the mother chain?
Well, actually, asynchronization is just one method call on our system. And actually, we push that forward. We deploy a smart contract in a microchain. So meaning all the microchain, inside the microchain, you will execute all the functions on that smart contract. The microchain acts as a pretty much a independent blockchain that has its own state and all the transactions being recorded inside the microchain. But there is a major difference between our microchain and sidechain solutions. So you may think that sidechain will be pretty much close to what we have, but actually it's not. So basically, I want to elaborate a little bit. So sidechain typically has its own network, maybe a small number of nodes, try to compensate, the communication cost. So it will have a much higher throughput than the root chain. So that's what typically sidechain does. So we'll have communicated with root chain when necessary. But actually itself is pretty much a standalone sidechain. But in our microchain and mother chain setup, it's not that totally independent. The traffic between the microchain, they will route through the bottom mother chain communication layer and to the other nodes inside the microchain. So we do this for two reasons. One is, for security, because if we have a smaller sidechain, they can communicate with each other, and the number of nodes typically are very small. They are very prone to DDoS attack. So if I want to attack a sidechain, it's much easier than attack the root chain. So meaning the sidechain can only support a very, very small amount of value of the root chain. If it supports a value more than more than its security level, it will be easy, be an easy target for hackers. So in our microchain setup, all the communication between microchain nodes are not directly connected. They are routed through the bottom layer. So meaning if you want to attack a microchain, even it only has maybe 100 nodes, you still have to attack the whole network, which is bottom layer, which is POW setup. Meaning we will have thousands of nodes or 10,000 nodes. So that's the security comes from. So that's the difference between our microchain and the sidechain.
Okay. Gotcha.
So David gave a lot of the details, including how to maintain the security of the microchains. But to give you a simplified answer, how to do asynchronous calls. For the other blockchains, all the smart contracts are on one chain. So if two different applications are running their function calls, it has to go one after another. However, on MOAC, every microchain, every smart contract is a microchain. So two microchains can run at the same time. They don't have to wait on each other. So that's how we implement the asynchronous contract calls.
Oh,
and then, of course, David add how we make it secure to have these contracts run on the microchains.
Great. So, Raymond, with that, you can probably there's going to be, at some point, millions of microchains running at the same time. Is there an upward limit of how many microchains there can be? Does it depend on anything?
Theoretically, I don't think there's a limit. That's why we're saying, MOAC is scalable. We can scale up to millions of microchains. But of course, technology grows, hardware grows. We'll have to wait to see how it performs in the future. If we do have thousands and even tens of thousands of applications that comes to MOAC and build the apps on MOAC.
Yeah, I want to add a point here. So basically, theoretically, the scalability will increase as you have more microchains. So it's unlimited, but in technical detail, because all the communication between microchain nodes, they will eventually be routed through the bottom layer. So the network bandwidth in the bottom layer will be the major limit point to the ultimate throughput of the whole system. But we have multiple solutions to improve that performance in the coming months. So I don't think currently the bandwidth will be a major limit right now for our system. So theoretically, we can achieve a very, very high performance in our system.
Great. Now, one of the possible solutions that I saw mentioned was sharding. Can you describe where the sharding fits in your ecosystem and how far along you are in developing that?
Yeah, actually, already, as I described before, we already implement sharding in a microchain level. So basically, if you have multiple smart contracts, you would deploy each smart contract as a microchain, and each microchain only use a small number of nodes from the system. So basically, that's a type of sharding in a smart contract level. So assume I have like 10,000 nodes while doing the smart contract processing. And when I deploy a smart contract, unlike in Ethereum system, all the 10,000 nodes were processed in the same smart contract at the same time. I only need to randomly select like 100 nodes to process the smart contract for my microchain. And now for the 10,000 of nodes, it can process 100 smart contract or microchain at the same time. Now we get 100 speed up. So in that manner, you can consider this as we shard each smart contract into a microchain.
Mm-hmm.
Yeah, this is a very interesting topic, so I want to add something to it. I joined MOAC this January, but before that, I was actually doing some research on blockchain, and I see one of the biggest problem we have with blockchain is the limit of speed. We can process a lot of transactions on blockchain, and then we have this concept of sharding. But when I look at the sharding, I don't think this is the ultimate solution, because you say you have 10,000 nodes, you break them down into 100 shards, so you can process 100 times faster. But still, the smart contract calls, the balance transactions. So that is why when I see MOAC, I think this is a better solution, because with the microchain solution, every microchain is supporting one application. And I feel this is a application-oriented architecture, which I really liked. That's why I joined MOAC, and I think this will be successful.
Great. So you mentioned kind of the application focus of this. Right now you have about 20 dApps, maybe more, available. And by 2019, you're planning on having 100, mid-2019, even more than that. So can you tell us about some of the dApps that you have and maybe how people can get involved in building dApps on MOAC?
Yeah, we have multiple applications been running our system already, and there are many of them. They try to talk to us and see how they can, utilize our advantage to promote the application. So the applications running our system can be categorized into multiple categories. One is game, crypto games. Typically the games in Ethereum suffers from the lower TPS and expensive gas. So this time they don't have this problem. And another category is like financial related application. You know, they want to use the token as a incentive of their workflow. And there are some other very interesting applications relate to the digital assets. Could be a file download, and it's maybe the file's copyrights management and some other digital assets. So here I want to add, so why they want to choose our platform instead of Ethereum. I think when we designed this system, we redesigned the workflow of the APB in two ways. One is we get rid of gas requirement in our microchain. So everybody knows gas in a blockchain system is very important. It provides security and provide incentive for the miners to process your transaction. If you don't have this, no one will work for you. And the second thing is we get rid of the burden on the user. Rather, we put the the app developer will pay for the cost of the system. You know, if you use a blockchain system as your application platform, someone need to pay the resource. It could either be processing power, it could be file storage, but someone have to pay for it. In all the blockchain system, most of them require the user to pay for that. But in our system, we ask the app developer to pay the cost and leave the user be gas-free.
Mm-hmm. Great, great. So in terms of development, how far have you come so far, and what have you got coming up?
We have been developing a MOAC project since January 2017, and we are in full speed up July last year, and being developed on this for more than a year, maybe a year and a half. So we reached multiple milestones already. So by end of April this year, we launched our mainnet, and it's been running already for 3 months, and we already we get like 1% of total hash rate of Ethereum in like 2 weeks after the mainnet launch. And by end of last month, we released 2 microchain implementations in our testnet. So one is Raymond's been working on. We call it Firestorm, which is it's a similar implementation to Filecoin. It provide a quality service over IPFS network, provide decentralized file storage for all the applications. And the other one is we call it Clock Wind, which is provide the processing power for all the general smart contracts. And we are going to release those 2 implementations to the mainnet by, well, actually tomorrow we will release this on those 2 microchain implementation in our mainnet. So everybody should be able to use our microchain features to try out, if you want to deploy application, how you can utilize our microchain concept.
Mm.
So today is actually a big day. We're releasing the new version of our mother chain, and that supports the microchain. And we have about 15 dApps in our pipeline in English-speaking countries, and then about 10 in Chinese, in China. So yeah, we have many dApps that's waiting for the microchain to be launched, so they can start to put their dApps on MOAC.
Wonderful, wonderful. So tell us a little bit about your team, because I noticed on your website there's only kind of the 4 leaders of your team on there. Is the team bigger than that? And well, obviously with Raymond, I see it here, it obviously is bigger, but can you tell us a little bit more?
Yeah, so our team actually been together in the blockchain field for the last 4 years. We start, looking to the blockchain technology since 2013. And we have a core team been working on that since then. So we have about 9 full-time employees in the United States, and we have 6 more full-time engineers in Shanghai. And we have like multiple part-time engineers contributing to us.
Mm-hmm. Okay,
so that's all the technical engineers, not including the operating and other marketing stuff.
Great. One thing I see here that I didn't touch on was the cross-chain link you have there. Can you tell us a little bit about that?
I think Raymond may have a better explanation, because the Firestorm he has been working on is actually a cross-chain feature, but it's not cross blockchains. It's cross our blockchain with external IPFS network.
Okay.
Yeah, so because we have this mother chain and micro chain architecture, in order to do a cross chain, we can dedicate one of the micro chain to cross from MOAC to any other chain. So if we want to cross with Ethereum, then we will have a micro chain that was dedicated to do the cross chain features between Ethereum and MOAC. So theoretically, we can cross chain with every other chains. But the one that has been implemented, which is the one that I'm working on, is a cross-chain feature with MOAC and IPFS. So IPFS is a protocol for storing files on a decentralized platform, and it has its own network. And then of course MOAC microchain, you have the microchain SCS smart contract server program that is used to maintain the microchain. So in order for us to do the cross-chain feature, what we're doing is we will have, most of the time we'll have 2 components. One component is the MOAC component. Another component is the component for the other blockchain or any network or platform. So we combine those 2, and then we implemented the cross-chain feature in our microchain SCS, and then that way we can run the transactions on a MOAC microchain, and then make changes on the other network or a blockchain through the component that was installed. So in this example here, on the Firestorm microchain, people can use MOAC transactions. They can do a contract call to store the files into the Firestorm microchain, and then the files will be actually stored into the IPFS platform.
Okay. Yeah, so just to add a little bit point, so basically we can implement a microchain to do specific cross-chain communication. One microchain for cross Ethereum, one microchain to cross BTC. And we don't have any special requirement for the the BTC or Ethereum to the hard fork to support the cross chain. They can stay what they are right now, and we just need to implement a microchain consensus protocol to cross BTC or Ethereum or any other blockchain systems. And we have already an example for that.
Great. So one thing I'd like to hear the answer from both you, David, and you, Raymond, is what excites you the most about MOAC?
I want to share some, points when I went through this. So when I first designed this system, we tried to solve a lot of problems that Ethereum wasn't able to. And I will come up this architectural setup. And surprisingly, when we initially designed this, we didn't see to support cross-chain features. We don't see, we can cross-chain, IPFS network. But over the time, when we're doing this, we found it so easy to implement this with our microchain concept. So that's really, make me, feel really good. And also it seems like to, let me know that we must do something right. This kind of problem, like cross-chain problem, is typically very difficult. And everyone in blockchain system tried to solve this problem. And we found it so easy. And we spent only, like Raymond spent only 2 months, and we already finished a Firestorm microchain, which is a Filecoin tried to do.
Mm-hmm. Wow.
And for me, and I think I already answered this question, it's the architecture of a MOAC that I think it's better than a lot of the solutions that's out there. And then when I joined in January, for the first time I saw what those guys did, it was awesome. It was amazing, eye-widening, right? So that excites me. But at the same time, I know it's not perfect, so there's still room to improve, and I can still be part of it. So that's why I'm here, and I'm happy.
Great. Well, that's exciting that you guys have been able to solve a lot of the problems that have been out there and do it in such a short time frame. I guess before we finish this interview, is there anything else that I didn't really touch on that you'd like to mention in this?
Yeah, I want to add a little bit points here. So if you look at our microchain, you may think it's solved a specific task, or it's corresponding to a specific application, but actually you can look above at one more level. If those microchains could be treated as service. So if you want to build an application on a microchain service, then your application can utilize the service from multiple microchains rather than just a single microchain as application. So consider this case. So if you want to build a really powerful application, decentralized application, like you take one microchain as the I/O, so that microchain may be a IoT network. So doing the data collection, and then you get the data and pay for those data and get those data stored into another microchain, which is a service like just Raymond did, like Firestorm microchain as a service. So you get data from one microchain and store into another microchain as a decentralized file system. And then you have another microchain which maybe consists of like a lot of GPU-enabled miners, which they can do deep learning, right? And then this deep learning microchain will get data from decentralized file system as input and do some meaningful processing and output. So now you can build a really powerful application, decentralized application, on top of multiple microchains if they can be shared as a service. So we brought up this concept called microchain as a service. So your microchain cannot just only be an application, it provide a service for the other applications. So in that way, we provide a really powerful architecture to build a really powerful applications.
Mm-hmm. Yeah. And I just want to shout out to your followers. We have a YouTube channel too, and there are a lot of videos out there. It's very technical oriented. If you want to learn more about MOAC, you can come to our MOAC channel too.
Okay, awesome. Yeah, MOAC channel. And for anyone who wants to find out more information about MOAC, where would you recommend that they go?
Well, I think first go to our webpage, moac.io. There's a lot of information, and also we are trying to improve our developer community, and there's a lot of information you can reach.
Mm-hmm. Yeah, I got to say, your website looks very nice.
Thanks.
Thank you.
Yeah, you're welcome. Well, David and Raymond, it's been an absolute pleasure to have you both here. Thank you so much for joining me for this interview. And then, we'll catch you later.
Great. Thank you very much.